So here is the answer to the two questions I had put onto the exit ticket for today's lesson. This originally was something I had originally done in the actual live lesson, so that's why you're seeing it says breakout rooms. But here you're given that these two triangles, and there is some overlap between them, and that AE is congruent to BE, and angle C is congruent to angle D. And you want to be able to prove that triangle ABD is congruent to triangle BAC. Now you were asked to just give the reasons for the statements in the proof. So you're going to see the statements come up along with their reasons. So now this one just says mark the figure appropriately, but basically we're just taking the given information, AE congruent to BE and angle C is congruent to angle D, and just marking it. So on your exit ticket, you had that, basically AE is congruent to BE and angle C is congruent to angle D being stated again, and of course that was from given information. I also know that angle BED is congruent to angle AEC because that's the vertical angle theorem. You can see their vertical angles, and I was showing the markings, what the statements were saying, because sometimes if you see what the markings are, you have a better idea of what's being used to state them. I mean, that's why it's a good idea for you to put markings on once you establish congruence and things of that nature. So, because I do have two congruent angles and a non-included congruent corresponding side between the two triangles, by AAS, the triangles are congruent to each other. That means that I can say that segment BD is congruent to segment AC, and segment ED is congruent to segment EC, by corresponding parts of congruent triangles being congruent, or CPCTC. By the segment addition postulate, I know that AE plus ED equals AD, and that BE plus EC equals BC. So that's a segment addition postulate. And because, I have these two bigger segments, AD and BC, being made up of parts that are congruent to each other. So I know that AE is congruent to BE. I know that ED is congruent to EC. Because of that, so either transitive property or substitution, here it says substitution, I can say that AD is congruent to BC. What I'm doing here is I'm basically establishing what I need for my triangles. I could go a couple of ways with this. I know that AB and BA is congruent to each other. And I'm looking at these triangles here. I could have also stated that angle D is congruent to angle C again. This one was going a different route. I mean, so here it's making a statement that these two sides are congruent. So I could say that the triangles are congruent by side, side, side. I mean, you could also make an argument that the triangles are congruent by side, angle, side. I mean, because once I established that AD was congruent to BC, I would have had a side, angle, side setup. But the logic of this particular proof is showing, we're setting up side, side, side. Excuse that. The other questions you were asked were about, what additional piece of information is needed to prove the triangles are congruent by the hypotenuse leg theorem. Now, you have to remember, for me to use the hypotenuse leg theorem to state that triangles are congruent to each other, I have to have first two right triangles. They have to have a pair of congruent hypotenuses, and they have to have a pair of congruent legs. And they have to be in the same relative position with each other, although that's not hard to do. Hypotenuses are always across from the right angle. A leg is a leg no matter which way it's oriented. So when I look at this one here, I have two pairs of congruent sides. So hypotenuse leg, I don't need the third sides being congruent. What I do need is these to be right triangles. So what I would need essentially is for angle A and angle Q to be given as right angles, based off of the way that the picture looks. I could also say, I could have also said that angle E and angle S were right angles, but they don't look like they'd be the right angles of these two triangles. I mean, so that's kind of far-fetched. But it would also work if that happened to be the case. Because if you don't have right angles in the triangle, they're not a right triangle, therefore you won't have a hypotenuse, and therefore you can't have a hypotenuse leg theorem. The second one you were presented was this here. Now this one here shows two right triangles. I have the legs here and here. So what I would need are for me to know that the hypotenuses are congruent. So for me to use the hypotenuse leg theorem for this, I'd have to know that side LN is congruent to side XZ. I mean, there's other things I could know about the triangles to help me prove that they're congruent, but you know, this is one that's specifically congruent by hypotenuse leg theorem, or as we call it, HL. And there's always questions like this that, you know, they're asking for a specific theorem to be used. So, you know, make sure that you know that you're setting up the particular theorem. Don't just set up a situation where the two triangles are going to be congruent and think it's going to answer the question. That's all I have for this video. So if you have any questions, please feel free to get in touch with me or your geometry teacher. But until I get to see you in another live lesson, or if you're one of my students, I speak to you on the phone, I wish you a good day.